Okay, topic 4.5, interpreting the context of the vertex in a quadratic regression model. All right, so the vertex, the minimum value of the parabola. You can access that information from the graphing calculator, which I'm going to show in a moment. But remember, we're talking about this quadratic model in the same situation, bill versus tip. We said the quadratic model presumably matches the data better, so we want to look at the vertex and see what that means. What's the minimum value? Does it make sense? So the vertex here is 25.68 comma 5.175, right? I did some rounding, obviously we can see from this screen. But first, what is the vertex? Well, that's just your round whatever number is given to you on screen here. Okay, now, meaning of the vertex. Basically, vertex is either a minimum value for a concave up quadratic function, or it's a maximum value for a concave down quadratic function. So there's a negative out in front of the x squared term for concave down. You can see that in your regression equation. So you're looking for a maximum. The minimum is if there's a positive x squared in the quadratic equation. All right, so this will be relevant in the calculator functions in a moment. So we have the vertex here. I'm just going to show you how to do it really quick in the calculator. I've entered all my data already. This is my quadratic graph. In order to access the vertex, you go to the calculate menu. So you go press second and trace. Calculate calculates various things about or aspects of a function. Here you're accessing just the minimum or maximum. Now you have to tell the calculator which one it is. This is a concave up function, so we're accessing the minimum value. I know it's concave up because of the positive coefficient to x squared. So you need to look at your graph and understand whether it's a minimum or a maximum. Okay, so we can see from this slide previously, right, that this is a concave up function, and we're looking at a minimum. So back to the calculator, press 3 for minimum. And then you see it has this cursor that's blinking over here somewhere in the function. You basically want to go to the left of the vertex. That's what left bound means. So I'm just clicking until I see my cursor go over to the left of the vertex. Now you can choose here, it can be over here, it can be anywhere as long as it's left of it. So you press enter. And then you go right. Make sure you scroll back with your cursor to the right of the vertex, which is then, I'm going to say, is over here. Press enter. Guess, just press enter again. It means it's going to give you a guess. That's my minimum value. So that's how I got that, and that was on the previous screen from the slide. Okay. Back to the actual question and context here. So we know that our vertex is this coordinate point. Now, how do we frame a coordinate point in the context? Well, it's two values, it's two numbers. What do they mean? They're matching, right? This is a situation where these is like an input and an output. But basically, think about this as the independent variable, comma, the dependent variable. So what you want to do is write each value in the coordinate point, including their units from the context. So what's the context of the independent variable? What's the context of the dependent variable? In this case, it's dollars, right? $25.68, comma, 518. So what does that mean? This $25.68, that's my independent variable, right? My total bill, my dependent variable is my tip. So this means $25 of a bill, $5 of a tip. So what does that look like in a sentence? The quadratic regression model's vertex represents that someone will tip $5.18 on a $25.68 bill at the restaurant.